Okay, so for this exercise, we're going to pass by value to a function that will take 3 arguments. So it will, in its parameter list, it will have 3 items. Notice that in main, I have 3 variables. 2 of them are integers, and 1 of them is a character. And I'm asking the user at runtime to enter values for these variables. What we're going to do is pass them to a function that will print their content. And let's go ahead and write a prototype. We could do an informal prototype. So again, void, which means the function returns nothing. In another lesson, we're going to learn functions that have something else other than void. So let's call it my print. So it's your function. And it will take a char, comma. So I'm just informally, writing the signature for this prototype. Could I have done char, c, comma, int a, int b as local variables for that function? Yes. But anyway, so int and int, this takes us into what we call an informal prototype, which means we don't have necessarily a variable next to the data type, but it tells us the signature and the way the function will be called. You will have to pass a character as the first argument. Second argument will be an integer, and the other one will be also an integer. Let's go ahead and also add a float. Why not? So let's do a float, num3. And what we're going to do is enter printf, enter decimal number or a real number, right? So that would be scanf. So this time we're going to have 4 items. Just show you that you can have different data types. You can mix it up. So %f and %num. Okay, semicolon. And now what I'm going to do is have it where the last item is an actual float. Now let's define this function with this particular signature. So we're going to do this. Void myPrint char letter. You can call it my letter if you want. You could call it C. You could call it whatever you want. It is not the same as my letter that we declared in main. This is a local variable to my print function. So you can name them whatever you want. And that's the advantage of local variables. You could reuse names. So int, and I could make this a, or just simply n1, int, n2, and then float, n3, right? So I've got 3 numbers. These are my local variables, letter, n1, n2, n3. And they will eventually, when I call this function, they will have a copy of the values we pass to them. Well, first, let's go ahead and do the print function that we want. And character passed is, and then %c, and then let's do a /n here. Gives me a new line. Numbers are, and let's do n1 equals /n. Oops, you're going to have to put a %d here, /n. That gives me a new line. n2 equals %d /n. And then n3 equals, and that would be a %.1f. So we're going to keep it at 1 decimal point /n. Now I've got 3 items in there. Letter, in that order, n1, n2, n3. Okay, so these are going to fulfill the placeholders here. %c will take the letter, and this should be n1, not m1. This %d will be N1, that's in here. This percent %d right here will be N2, that's right here. And this percent 0.1f, so basically 0.1 sets the precision to 1 decimal point. And that will be for N3 of type float. Now we need to call that function, right? I can compile this, and if you run it, nothing happens really in terms of printing out because we never call this function. Let me just compile to make sure I don't have any syntax error, and I do. Yes, right here it's called num3 instead of num. You can see here I had num, and I never declared it. I had a num3 here. So make sure your variables are consistent. This is why you compile, to make sure that everything is good. Now, let's go ahead and call the function. Let's do the function call. We're going to do it here, myPrint, and you're going to pass along everything in the same order as your signature. So my letter goes first, comma. You can pass A and B or B and A, depending on what is it you're drawing. But definitely the last one has to be a float, num3. Now that is my function call. So this here is my function call. So this is where the magic happens. Okay, when you call this function, it will execute what you've defined in this section here. The prototype simply tells the compiler, hey, there is a function definition called for myPrint after main. All right, well, let's compile and run this. Okay, so it's asking me for a letter, so I'm going to enter the uppercase Y. It's going to ask me for a value. We know it's an integer, and then a -1. Now this one will be a 3.4, and let's see if we get them. And sure enough, we do. Character passed is Y, numbers are N1 equal 2, N2 equal -1, and N3 is equal to 3.4. So as you can see, we can pass as many values to a function as long as you have the matching parameters for your arguments. Okay? Now, how far can you go? Typically, if you're going to go above 4, max it out to 5. If you're going to pass more than 5 items, you may want to think about your strategy. There are different ways to handle that. But at this stage, so we can see now that we can pass multiple values of different data types to a function. Our next lesson will be a function that actually returns a value of a certain data type.